Well, hi there. Welcome to another math lesson. Thank you for watching. So, we are going on. We are learning about rational and irrational numbers. At least we did a few lessons ago. And I want to focus on the rational numbers that are fractions. So today we're going to learn about adding and subtracting fractions with common denominators. So let's think about this. Erin walked 3/10 of a mile to the post office. So she went from home to the post office and she walked 3/10 of a mile. Then she walked to the library, which was 5/10 of a mile. And the question we're trying to figure out is how far did she walk altogether? Well, let's see how we do that. 3/10 plus 5/10 will give us how many tenths she walked, right? So let me write this down as a mathematical problem. I'm sure you've already figured it out by now, but let me show you how we do this. 3/10 plus 5/10. Now, when we want to add up fractions or subtract fractions, notice our denominators are the same. We do not add them. Okay, that is a big no-no when we're adding and subtracting fractions. We just copy it down because we are still adding apart. Okay, the bottom is how big is the whole, and I'll show you that in a few minutes with a pizza. Of course, we got to work food into it, right? But we're adding up how many pieces of that whole, so we don't add the bottom, all right? So on the top here, we have 3 plus 5, which is 8. So Erin walked 8/10 of a mile. Now, let's see about, Mr. Horn would like this illustration. This is a little different. Harper has a board that is 7/8 feet long, okay? And he cuts off a piece that is 5/8 feet. How long is that board now? So the board started out at 7/8 feet, and he cut off a piece. That means we're subtracting that piece that is 5/8. Now again, 8/8 would be a whole, all right? 7/8 minus 5/8, we do not subtract our 8 because that would give us a really bad fraction. Zeros in the denominator are very bad fractions. But we're not subtracting a whole thing. We're subtracting just the top number, just our numerator. 7 minus 5 is 2. So we get 2/8. Okay, that's what's left of the board. Let's look at one more example, and then I'm going to ask you to see about answering something. So here's Roger. Here's that pizza illustration I was promising you. He cut a pizza up into 6, and he ate 2/6 of the pizza. Jenny ate 1/6, and Tony ate 1/6. So we got 2/6, 1/6, and 1/6. Now the question asks us how much of the pizza is left. It doesn't ask us how much they ate, do you notice? So if I add those three numbers and stop, I didn't answer the question. All right? I need to add those three numbers and then subtract it from the whole pizza. Make sense? So if I add these three numbers, again, we do not add these down here. Why? Well, let's look. How big is the pizza? It's 6 pieces, right? The whole thing is 6 pieces. We're just talking about the pieces that they ate. All right, so if we add 2 plus 1 plus 1, we get 4. 6 is how much they ate. Let's take a look. So I happen to know Roger, and he is a meat lover. So he ate the pepperoni and the bacon. And I know that Jenny, she likes shrimp. She's a seafood lover. So she ate this piece over here. And Tony, he's an onion and olive guy. So he ate this piece over here. So how many pieces are left? 2 pieces. But wait a minute. What I just did gave me 4/6. Well, if you look here, they ate 4 pieces. That's how much they ate. And you can see in the illustration that they have 2 left. But how would we do this if we didn't have a nice picture or if the fractions were weirder and harder to visualize? Well, how much pizza is left? That means we subtract. So how many pieces of this pizza did we have to start with? Well, we had 6. 6 pieces cut into 6, right? The whole pizza was cut into 6. So this is actually a 1, right? 6/6 is 1. We subtract the 4/6. And again, we're subtracting. We don't mess Don't change our denominator. 6 minus 4 is 2, and that's what's left. There's our answer. Hey, your turn. You can do it. All right, number 2. And number 3. I know you can handle this. Okay, now that you've done a few problems as practice, let's take a look at this one. So if we do it the way we've been doing it, 11/12 minus 9/12, that gives us 2/12, right? 11 minus 9 is 2. But wait a minute. That answer isn't there. Did I give you the wrong answers? Actually, no. Now, I've let you add and subtract without worrying about simplifying. If you take a look at my answer, 2/12, and think about it, you'll realize that a 2 and a 12 can both be divided by the same number, a 2. So if I divide my 2 by 2, right? Divide it by 2 and divide this one by 2, I actually simplify this down to 1/6. I'm dividing the 12, okay? I'm simplifying it. Divide the top and the bottom so that I get 1/6. So I want to simplify, and therefore this question had that answer. Sneaky, huh? Well, that's the way math teachers like it. We always want you to simplify, and that's going to become a new big deal for us. So let's see that again. If I add these two numbers, I have 4/9 and 2/9. So I add my top, gives me 6. I copy my bottom, that gives me 9. Now let's think about it. That is not simplified because I can think of a number that'll divide into both. Yep, it's not 2 this time because 9's an odd number, but 3 will do it. Divide by 3, divide by 3. If I can divide both the top and the bottom by the same number, then I need to simplify. So the 6 divided by 3 is 2, the 9 divided by 3 is 3, and that's the answer the math teacher wants from you. Simplified. So remember, always now, from now on, simplify the lowest terms. Okay, do it again. Well, I hope that wasn't too bad, guys. Adding, subtracting numbers or fractions with common denominators. Notice we didn't change common denominators until we were simplifying, okay? But be thinking ahead. I'm sure you've seen it before. But anyway, tomorrow, adding and subtracting mixed numbers. What does that mean? Are they different colors? Maybe they're different shapes. Maybe they're different font. Maybe they're bigger and smaller. I don't know. We'll find out what a mixed number is next time. Bye. Thanks for watching.